Okay, solve each triangle, and you're going to be given some pieces of a triangle, and you're going to be expected to solve it. And what that means is they want to know every angle measure, every side measure. That's it. That's what it means, solve each triangle. And typically when they want you to do this, it's a right triangle. Once in a while it won't be, but most of the time it's when there's a right triangle, and you need to use a couple of things. One of the things is triangle sum theorem, where three angles of the triangle add up to 180 degrees. So if you know that right here, this is a perfect example. Well, how many degrees are in a right angle? Yep, 90 degrees. So you have 90 degrees plus 59 degrees plus another, I'll call it theta. All of those add up to 180 degrees. And when you subtract 59, you subtract 90 from both sides, you're going to find out that, whoops, that looks like 310 instead of 331 degrees. All right, so now that we know that, so what do we have? We have angle measures, we have one side. We need to know these other two missing sides. We need to know this side, and this side. So this side is, the side opposite angle A is lowercase small a. The side opposite angle B is lowercase b, and this is lowercase c. Notice side lengths are always lowercase. Angle vertex are always capital letters. So hopefully you remember that from geometry, but if not, okay, so we can use trig ratios, and that's what we're going to do. So what I recommend is writing down everything you currently know. So we know the measure of angle A is 59, we know the measure of angle C is 90, and then by using the angle sum theorem, oh, that ended up locking, that's okay. Measure of angle B is 31 degrees. Well, we need to know side A, side B, and we know that side C is 2.7. So trig ratios. So let's look at side A first. So side A right here, well, look at what we know. We know that side A is opposite the original given angle. This is the opposite side. And look at what we know here. This is the hypotenuse. So when you're looking at trig ratios, so TOA. So opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Well, we have opposite and hypotenuse, so we're going to use the sine of 59 degrees. So that's what I did. Sine of 59 degrees is equal to the opposite, or A, over 2.7. Now, how do we get the A? How do we get that A by itself? How do we get this by itself? Yeah, we would just multiply both sides by 2.7. And then you all can just put this into your calculator exactly like this. You type in 2.7 sine, it will give you a left parentheses, you'll type in 59. Make sure your calculator is in degree mode, right parentheses, and then you're going to hit enter. And it's going to give you more decimal places, but you can round to the nearest tenth. And right there, it's going to round to about 2.3. So this side right here is about 2.3. Now, if we wanted, we could use Pythagorean theorem and do 2.7 squared, subtract 2.3 squared to get about the b value, or we can just use trig again. So look at angle 59, and B is the adjacent side. So we have the adjacent side in the hypotenuse, adjacent and hypotenuse. So we're now going to use cosine. So cosine of 59 degrees is equal to B over 2.7. So we're going to multiply both sides by 2.7. And you're going to type that into your calculator exactly like that. And you're going to round to the nearest tenth. And you end up with B is about 1.4. And we're just going to call all of those units. So B is about 1.4 units. And then you could check. You could check in your calculator. 1.4 squared. In fact, I'm going to do that right now. 1.4 squared plus 2.3 squared is 7.25. And so now we just have to take the square root of that. So I'm going to store that and then do second, the x squared button, which is square root, and then second store, or I could have just retyped it in if I wanted. And it is 2.69, which rounds to 2.7. So it's always a good idea to check your work, but that's how you solve each triangle, using triangle sum theorem and then using the trig identities. All right, that's it for this one.